In this video, we are going to solve this equation. Now, the first step might not be so obvious. Some people might think there's a square root here, so let's square both sides. However, if we try that, then we'll actually end up with a degree 3 variable on this side of the equation. Consider this. Consider the polynomial inside the square root, x squared plus 3x plus 1. We're going to produce this exact same polynomial on this side by breaking up some terms over here. I'm going to break up negative 3x squared as negative 4x squared plus x squared. And I'm going to break up 5x as 2x plus 3x. Now, I'm going to rearrange these terms a little bit. I'm going to rearrange it like this. Negative 4x squared plus 2x plus x squared plus 3x plus 1. Now, notice that I've actually produced the exact same polynomial, x squared plus 3x plus 1, which was originally over here. It was under the square root. So, what's the next step? Well, now I'm going to move negative 4x squared and 2x onto the other side. If I do that, I will get 4x squared and then negative 2x squared on this side, and then plus the square root expression, of course. So that would be x squared plus 3x plus 1. This over here will be equal to this underlined polynomial, x squared plus 3x plus 1. There we go. Now, here comes the fun part. Notice that this over here, x squared plus 3x plus 1, is obviously equal to this entire thing over here, right? It's obviously equal to it. Now, this over here, x squared plus 3x plus 1, this is the exact same polynomial as this one. And this is equal to this entire thing. So let's substitute this entire polynomial, right? Let's substitute this with this entire thing, because it's equal to this entire thing, right? So let's do that. If we do that, we would get 4x squared minus 2x. And then now, because this over here is equal to this entire thing, we'll write this as plus the square root of, and then 4x squared minus 2x. And then plus the square root of x squared plus 3x plus 1. And now this over here is still equal to x squared plus 3x plus 1. Nice. Now, you might see what we're going to do next. This again appears, x squared plus 3x plus 1 again appears in the square root. And this over here is equal to this entire expression again. So let's replace it with this entire expression again. If we do that, we would get 4x squared minus 2x and then plus the square root of x squared plus 3x plus 1. However, we would have this polynomial again, and we can replace it again with this entire thing. No matter how many substitutions, you'll end up with this polynomial in which you can replace it again with this entire thing, right? So therefore, we can make infinite substitutions, and we would eventually get an infinitely nested root with 4x squared minus 2x and plus the square root of 4x squared minus 2x and so on and so forth. Now, this entire thing is now an infinitely nested root. We call it that. Now, for those of you who might have seen an expression like this before, you might know what to do. However, if you have not seen this kind of thing before, I'm going to show you what to do next. Let y equals to this entire expression up here. Then notice this. Because the square roots go on infinitely, right? Then notice that whatever we have in here, 4x squared minus 2x and then plus the square root of so on and so forth, this is also equal to y. Why? Why? Well, because y, this letter y, is equal to this entire thing, and it's nested within this square root as well. Notice that this is exactly the same thing as this entire thing as well, because it's infinite. So basically, we know that y itself would be equal to 4x squared minus 2x, and then plus the square root of, this entire thing is just y as well. It's an iteration. So this is what our final result is. Let's move square root of y onto the other side. Y minus root of y is equal to 4x squared minus 2x. And now notice this. Notice this. Square root of y is obviously the square root of y, right? and 2x is the square root of 4x squared. So we can do a bit of comparison, right? It matches. So therefore, root of y is equal to 2x. We're just comparing it. So we get this result. Now, because, remember, y was equal to this entire thing over here, which means it's equal to this, we can deduce that, well, y, first of all, is 4x squared. But because y is equal to this as well, then we can deduce that x squared plus 3x plus 1 is also equal to y, which is also equal to 4x squared. And now how hard is this? Now we have a quadratic. We can solve this. Let's move 4x squared onto the other side. We would get negative 3x squared and then plus 3x plus 1. Plus 3x plus 1 equals to 0. Now we can use the quadratic formula. We would get x is equal to negative 3 plus or minus square root of 3 squared, 9, minus 4 times a, which is negative 3, and then times 1, all divided by negative 6. Now, we can simplify this further, so we get negative 3 plus or minus square root of 21 divided by negative 6. Now, this plus or minus sign gives us two cases. So either we have x is equal to negative 3 plus root of 21 divided by negative 6, and we can multiply top and bottom by negative 1, so we get 3 minus root of 21 divided by 6. And then we also have x is equal to negative 3 minus root of 21 divided by negative 6, and you can multiply top and bottom by negative 1. You would get 3 plus root of 21 divided by 6. And now we have two answers, right? Not so fast. Notice, and this is something to be always careful about, notice that here on the left-hand side of the equation, this must be positive because there's a square root sign. This radical sign alone only produces a positive number. However, over here, we don't have a restriction. This can be negative, whereas this one has to be positive. So, if this is ever negative, then we have to eliminate a certain solution for x that makes this negative. Since this one, there's no way that this will equal to this then. So, we need a test for both values. I'm not going to test them. Well, I'm not going to write the steps on the board, but you can substitute these two, either, do some handwritten math or into your calculator. And you will see that this one actually does not work because this makes this side negative. However, this one actually will work. This one will work. So be careful. That's a very common mistake that people might make. They might just, get x and, oh, I have two solutions. But be careful of the original equation. You must always be careful of what the original equation is asking for. That's going to be the end of this video. If you found this video interesting, then please do consider dropping a like and subscribing. Thank you very much. Bye.